in Desmos depicts the situation. The black curve is one branch of this e to the y plus y times the quantity x minus 2 equals x squared minus 8. This is the linearization. L of x equals 3 times the quantity x minus 3. And if I find L of 2.8, I get negative 0.6. And here is that 2.8, like it's pretty close to being a point that's on the curve of that function. The question is, how do you arrive at that? So we want to use implicit differentiation to find a formula for the slope of that tangent line. So with respect to x, the derivative of this first term is e to the y times y prime. That's the chain rule. Here, for the second term, we have to use the product rule. The first function y times the derivative of the second, and I'll put 1 here for emphasis, plus the second function, which is x minus 2, times the derivative of the first, which is y prime. You might be asked to write y prime as the dy over dx, but I like to use just y prime. The derivative of x squared with respect to x is 2x. Okay, so the two terms that have a y prime in them are this one and this one. So I'm going to picture taking this y to the other side of the equal sign, 2x minus y, and factoring out the y prime from those two underlined terms. That'll leave e to the y here and plus x minus 2 from that second term. And then if I want to solve for y prime, this is my formula for slopes of tangent lines. To the graph of that implicitly defined function. Now, I would like to find the slope of the tangent line at the point 3, 0, because we're going to use that so that I can write the equation of that tangent line. So I want to find y prime of 3, 0, which means put 3 in for x and 0 in for y. So in the numerator, I get 2 times 3 is 6 minus 0 is 6. And in the denominator, e to the 0 is 1. 3 minus 2 is 1. So at 3, 0, the slope of the tangent line is 6 over 2, which is 3. And the point that the tangent line is passing through is 3, 0. So I just use point slope. Slope is 3, the point is 3, 0, so y minus y sub 1 is y minus 0 equals the slope times the quantity x minus x sub 1, and x sub 1 is 3. So there is the equation of the tangent line. I could write that as 3x minus 9. But the point is, if I put 2.8 in for x, that'll be an estimate. As long as we're pretty close to the point 3, 0, that'll be an estimate for the point that's actually on the curve. So if you put 2.8 in for x here, you do get this negative 0.6. Okay, hope that helps you understand this problem.